and we will see all these topics in the next many slides and discussions and next many lectures. uh, it is also used in the production of APIs also. Water is there to maybe dissolve those things, or maybe in the part of the reaction also, and in the production of intermediates are the kind of compounds which are then further processed to produce the final APIs. And analytical reagent, many analytical reagents like you may are prepared with the help of this water. uh, as you see, naphthalene, simply methyl red, etc. All these things are dissolved in this water, and certain other things are also added to different reagents, and you have practiced in the class of the chemistry. So and as a whole, it is also used in the labs for the cleaning of the glasswares also, and the equipment there also is cleaned by this compound, or the important aid, water. And definitely it has many different grades which are used to uh, uh, to be utilized for the certain kind of specific requirement. And also it is nowadays it is sold as the drinking water in the bottles. So it is in the chemistry, in the pure chemistry, if we see it is composed of two hydrogen atoms and one oxygen atom, we can see. And in liquid state, mostly the word water is used for its liquid state, and when it is in liquid state we call it water, and when it is in gaseous state it is called steam, and if it is solid then we call it as ice. So three different terms we daily use: steam, ice, and water. And there is some other state also. Many fluids can attain this state, and you may have studied in the physical pharmacy or physical chemistry topics. You have already studied the supercritical fluid. And at the critical point, the fluid has the properties of gas, and the solubility properties of the liquid. It can penetrate through materials, like a gas can penetrate, and then it can dissolve the things like a liquid. Then this is very important. Especially maybe you have studied that in the chromatography chapter, in the topic of the chromatography, supercritical CO2 chromatography. These topics are prerequisite of this class of this class, means this topic of industrial pharmacy. And in the polarized form it exists as proton and hydroxyl. And the origin you make study from the slide, how this word water came. The formula, if we talk about the chemistry, then molecular formula is H2O, molecular weight is 18.0153 maybe, and this is the number CAS, chemical abstract service registry number, is important. And usually this is most important thing. maybe not for this topic, but for all other chemistry topics and chemistry compounds, this is the most important number from which you can identify which kind of compound is this one. This is the specialized identity of the compound. So structurally, how we depict it, like it is depicted like this: two hydrogens attached to a certain angle to the oxygen atom, and this is computed 3D. This is computed 3D model of this molecule, and these are the exact angles that you can see how actually these atoms are attached to the oxygen atom. Hydrogen atoms are in white, and the red one is the oxygen atom. And there are many other forms, as you know. The isotopes of the water, isotopes of hydrogen are there as a deuterium, protium, deuterium, and tritium. So, and oxygen does have these different isotopes also. And the important waters we usually see as a deuterium water, D2O, where both the hydrogens are replaced with the second isotope D, and then that becomes the D2O. And there are other specialized water types which are used in the chemistry and some other fields, which is which contains one tritium atom and one hydrogen atom and one oxygen. And there is one water with oxygen mass of 18, water 18, oxygen 18, and the water D, where one molecule is the molecule contains one deuterium and one protium, and water T2 is the same, 2T and oxygen. And many other nomenclatures may exist, which you can see that to the left side of this presentation, and hydrogen monoxide, dihydrogen oxide, or other, but we usually don't deal with this. HOH or HHO, maybe sometimes people say it. You may hear these terms in your daily life. Let's go to the next topic, and certain facts about this. You may have studied all these things before. Found in all living organisms, and the most of the part of our body is also water, because cell contains 75% or more water, and it is transparent and nearly colorless. It is called in the liquid form, and large volumes, as you see in the sea and rivers, it tints like blue, and it should be colorless, flavorless, and odorless. And the water we use in daily life, it also possesses these three characteristics. It should not be colored and should not have any flavor, and no odor should be coming out of it. And 2.5% of fresh water that we see in the earth, and out of this 98% of this is 98.8% is in ice and in groundwater. So mostly water is deposited on the mountains and the areas where it is in the form of ice, and the remaining water is in the ground. And these are certain other properties, that because it is transparent in visible light and near the UV and near IR regions, but in IR region it absorbs. And you may have seen in analytical chemistry class that this absorbs in the region of 3000 and 3500 to 3000 region. It 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 makes a big broad dip in the infrared region, and it also absorbs ultraviolet and microwave radiation. Microwave radiation, you daily use microwave oven to warm up your food, and sometimes I make tea and coffee in microwave oven. So how the things get heated, because those contains certain moisture content, or almost liquid is there. When I make coffee or tea in it, then 100% water is there with the tea bag, and these water molecules get heated because they can absorb microwave radiation. So microwave radiation definitely gets absorbed in your bodies also. And it is the why we are discussing it so heavily in the production of pharmaceuticals, because it is an excellent solvent and dissolves the polar compounds are readily dissolved in it, like acids and also alcohols. Also polar alcohols are polar, and many salts are get dissolved in it. Certain other concepts are also there in the chapter of botany, or maybe in pharmacognosy. You may have studied these concepts of the capillary reaction in the roots, and also in the pure chemistry class, physical chemistry class, you may have studied this capillary reaction, and it is due to the adhesive and cohesive forces, and hydrogen bonding between the molecules also makes its surface tension. That's why you have seen certain small insects. I have observed also that those float over the surface of this water in the liquid state, and also can move on the surface of the water. And this hydrogen bonding that causes the surface tension, and that's why the insects and a few small animals can move. Pure water. This we will never see in our pharmacy or in pharmaceutical production, because we never use this kind of water. Pure water is an electrical insulator. Maybe in someday, but I have never used it. However, deionized water is it contains a few ions also, and sometimes it undergoes autoionization also. Okay, and we never see that it is insulator anymore in our pharmaceutical field of pharmaceutical production. And small solutes are always dissolved, and we get a controlled conductivity of the water for our purposes. And we will see all those parameters according to the official compendia, how to regulate this parameter of the conductivity. Density of water is 1 gram per cubic centimeter, and regular ice is less dense. We have seen ice floating on the liquid water in the movies and the documentaries, and also we see in our own area here in where we live in Ahmedabad. We can see in the winter sometimes. So let's go to the next topic, and this is most important, and it is about the types of the waters. Yeah, this is complicated because water is water, but why it has the types? Let's see. For the pharmacist and the pure chemist, this is most important topic, because water must have to be in a certain characteristics to be used for a certain kind of special purpose use. So one is non-portable water. In this discussion, the first slide, we will only see the list of things: non-portable water, portable water, purified water, water for injection, biostatic, bacteriostatic water for injection, sterile water for inhalation, sterile water for irrigation, water for hemodialysis. What is non-portable water? It is the raw water, means it is not for the drinking quality, but it can be used for other purposes, depending on its quality and the kind of the purpose we actually want to use it for. It is untreated water, so coming from lake, rivers and groundwater, springs and wells also. It is this kind of the water is called non-potable water. So purpose is to clean outer surface of we are talking about the sterile manufacturing, so we can say that it is used for the cleaning of the outer surface of the factory or the production facility. We do not use untreated water inside, and used in gardens and vehicles, washing of the vehicles and the outside area of factory. Portable water is important, but it is not used for the pharmaceutical production or dissolving the things like that in the pharmaceuticals. It may consist and contains sodium, potassium, calcium and magnesium and some certain other things also, which we'll see in the details of the constituents of the potable water. So it is not used for this pharmaceutical production. We'll see how we'll use it. To use for the drinking purpose, washing and extraction of crude drugs, it can be used, and preparation of products for external use sometimes. Purified water, and this is the most important thing, and it is produced after certain proper water treatment process, and that process we will see in outline of the process we will see in this lecture, and the details of the water processing for the production of purified water we will see in the next lecture. So this water is the most important type of water which is used for the production and the washing of the equipment of the non-parental dosage form producing equipments and utensils and things like that, which we usually use in the pharmaceutical manufacturing facility, and also for the production of the solutions like the gelatin solution